Lussac's law of combining volume. Gay Lussac's law of combining volume states that when gases react, they do so in volumes which are in simple ratio to one another. Now, when hydrogen combines with oxygen, steam is formed. Actually, we are having a ratio of combination which is 2:1:2. So, which means the volume, 2 volumes of hydrogen requires 1 volume of oxygen to form 2 volumes of steam. For example, what if, for example, the volume of hydrogen I'm having to take part in this chemical reaction is 10. Remember that the mole ratio is that 2 volumes of hydrogen requires 1 volume of oxygen, which means 10 volumes of hydrogen will require 5 volumes of oxygen, produced 10 volumes of water. Alright guys, are you having problem performing calculation that has to do with Gay Lussac's law of combining volume? Worry no more, because this video is going to actually give you a perfect explanation to it. Now, first of all, let us even state Gay Lussac's law, or let's know what Gay Lussac's law of combining volume states. Gay Lussac's law of combining volume states that when gases react, they do so in volumes which are in simple ratio to one another and to the volume of the products that is being formed, provided pressure and temperature are kept constant. That's actually what the law states. So that's Gay Lussac's law of combining volume. So what are the key notes to take? The key notes are gases combined in volume, doing so in simple ratio to one another. Gases combined in volume, doing so in simple ratio, provided pressure and temperature are kept constant. Okay, now quickly, experimentally it was observed that when hydrogen combines with oxygen and water is being formed, the ratio for the reaction is 2:1:2. Now what does that mean? Now, when hydrogen combines with oxygen, steam is formed actually, and when this equation is balanced, of course, 2 in front of the hydrogen, 2 in front of water, and then 2 in front of the hydrogen molecule. So we are having a ratio of combination which is 2:1:2. So which means the volume, 2 volumes of hydrogen requires 1 volume of oxygen to form 2 volumes of steam. This can be predicted from a balanced stoichiometry. Of course, the mole ratio can be predicted from balanced stoichiometry. Now, for example, what if, for example, the volume of hydrogen I'm having to take part in this chemical reaction is 10? Remember that the mole ratio is that 2 volumes of hydrogen requires 1 volume of oxygen, which means 10 volumes of hydrogen will require 5 volumes of oxygen to produce 10 volumes of water. So take notes now that in this sense that 2 represents what? 10, and that's where 2 is actually giving us 10 of steam actually. Then of course, what if I have the reacting volume, I'm having 20 volumes of hydrogen available for this chemical reaction. Remember that from the mole ratio, 2 volumes of hydrogen require 1 volume of oxygen. That means that 20 volume of hydrogen will require 10 volume of oxygen to give birth or to produce 20 volumes of steam. Okay, now of course this means the reacting volume or the reacting ratio is 2 volumes of hydrogen against 1 volume of oxygen to give 2 volumes of steam. Now, okay, now calculation under Gay Lussac's law of combining volume. Now, for example, we are given a question. Of course, this is chemical equation to the question, and we're told that what is the volume of oxygen required to burn completely 45 cm³ of methane. Of course, the equation for the reaction was given. Now, how do I go about this? Remember, we are to calculate for the volume of oxygen. The volume of oxygen required to burn methane. So, volume of oxygen required to burn methane. Now, that is actually what we need. So, before you solve questions like this, please, you have to get the mole ratio for the reaction. And the mole ratio for the chemical reaction is from the balanced chemical reaction, the mole ratio is 1:2:1:2, which means one ratio of ethane, one volume of methane needs 2 volume of oxygen. Okay, and remember what you have to calculate for here. We are trying to calculate for the volume of oxygen that is required to bond 45 cm3 of methane. So class, from this actually we can all say that if 1 volume of methane needs 2 volume of oxygen, it simply means that 45 cm3 of ethane will consume times 2, which is 90 volumes of oxygen. 45 cm3 of methane consumes 90 volume of oxygen, of course, to produce 45 cm3 of carbon dioxide and 90 volume of water. So technically speaking, it means 45 cm3 of methane requires 90 cm3 of oxygen to burn completely. Of course, to burn. That is what it means. Alright, that is that. Okay, now we have another question. Here we are told that 20 cm3 of CO was packed with 20 cm3 of oxygen. Now, if all volumes of gases are measured at STP, calculate the volume of the residual gases. Remember, it is the reacting volume for the reactants here are carbon 2 oxide, and it was given as 20 volume. So carbon 2 oxide, and the volume is 20, combining with with oxygen, of which its volume is also 20. Now it means we are given the volume of two species in this particular question. So, and we are told to calculate for the residual gas. And what's residual gas? Residual gas is actually the gas gotten at the end, remaining at the end of the chemical reaction. So now how do we go about this? Of course, the chemical equation is given. Now remember, what are the volumes available? From the mole ratio, from the balance equation, the mole ratio for this chemical reaction is 2:1:2, which simply means that remember that what was given in this chemical reaction, I'm talking about the volume before the chemical reaction. From the question, we are told that 20 of CO was packed with 20 of oxygen. That means 20 volumes of oxygen. Of course, before chemical reaction, we don't have the product yet, which means 0 of CO2, which is the product. Now, what will now be the reacting volume? Class, now to take note of what will be the reacting volume, remember that from the reacting ratio, it is 2 volumes of CO that must consume 1 volume of oxygen, or 1 volume of oxygen consumes 2 volumes of CO, which is carbon monoxide, which means 20 volumes of CO will consume how many out of this 20? How many out of this 20 oxygen? So now, from what is given so far, remember that I can actually do this in a nutshell. I said how many volumes of CO? CO is 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And oxygen is also 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And we are told now that from the mole ratio, it takes 2 of CO to cancel out 1 of oxygen. That means 2 of CO cancels out 1 of oxygen, 2 of CO, 1 of oxygen, 2 of CO, 1 of oxygen, 1 of oxygen, 2 of CO, 1 of oxygen, 2 of CO, 1 of oxygen, 2 of CO, 1 of oxygen, 2 of CO cancels 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 1 of oxygen, then 2 of CO cancels 1 of oxygen, and then 2 of CO cancels 1 of oxygen. At the end of the day, we are now left with 1, 2, 3, 4, 5, then 6, 7, 8, 9, 10. We are now left with, at the end of the day, we are now left with 10 of oxygen that did not take part in the chemical reaction. Simply means that the reacting volume is 20 of all the 20 of the CO, all reacted with 10 of oxygen, of course, to give how many of CO2? which is 20, because technically speaking, from this we say 20 CO. From this we say 2 represents what? 20. That means 2 moles represents 20. So at the end of the day, class, our job now is to calculate for the residual volume. In order to get the residual volume, of course, the next thing I need to do is to know the residual volume, the remaining volumes at the end of the chemical reaction. So after the chemical reaction, remember that all the 20 available are reacted, which means I have 0 left of CO. All the 20 volumes of CO available all took part in chemical reaction, so I have 0 left. Then 20 volumes of oxygen, which was available, only 10 reacted, which means I have 10 left of oxygen. And then the final product, I will still be having 20 cm³ of final product, which is actually what is produced. So the residual volume becomes the total volume of what is remaining. The total volume of what is remaining after the chemical reaction. So total volume of what's remaining after the chemical reaction is 0 plus 10 plus 20. So technically speaking, it means I'm having 30 cm³ as the residual volume. Alright, so I believe that you can actually perform calculation involving Gay Lussac's law of combining volume. Alright, I'll see you in my next section. Bye for now.